Do you have difficulty with math? Worry no more, because I have a solution for you. Let's have math classes with Mamshi. See you in class! We are now on Calculus Week 3A, and our topic is about the ellipse. So objective is, at the end of this discussion, the students will be able to define an ellipse. Before studying the ellipse, we should recall the concepts in circles and triangle inequality. Take note that the equation of a circle is quantity x minus h squared plus y minus k quantity squared equals a squared. And if we are going to divide a squared on the both sides of the equation, equivalently, we get x minus h quantity squared all over a squared plus y minus k quantity squared all over a squared equals 1. And also, we have here the triangle inequality, which involves absolute values. And it is the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y. And this also tells about the vector addition, which states that the length of a side of any triangle cannot exceed the sum of the lengths of the other two sides, or else we cannot form a triangle. And so, we also have this concept about the perihelion and the aphelion. Consider a planet orbiting the sun. As you can see, it orbits the sun in what direction? And so, we have here the perihelion, which is the minimum distance from the sun, and also the aphelion, which is the maximum distance from the sun. And let me introduce to you Johannes Kepler. He proved that the orbits of the planets are shaped as ellipses, with the sun lying at the focus of the ellipse. So, this one is the sun, it is the focus of our ellipse, and the earth or this planet is revolving around the sun in elliptical direction. Let's continue with the definition of an ellipse. It is the locus of all points in the plane, the sum of whose distances from two fixed points, f and f prime, is constant. And so, later on we will know what are these f and f prime. Each of two fixed points is called a focus of the ellipse, and together we call them foci. Unlike the parabola, it is a closed figure, but like the parabola, it always devours its foci. As you can notice, this part of the parabola is facing here, and it devours your foci. And also, this part of our ellipse is here, and also, it devours our foci. And the line that passes through the foci is called the principal axis. But also, we can call this as your major axis. We have that major and minor axis. Okay, so we have here the parts of an ellipse. We have the center, which is found here at the intersection of your vertex and co-vertices. And also the foci, which is found here. These 2 points, your f sub 1 and f sub 2, are the foci or the focus of your ellipse. And they have the coordinates negative c0 and c0. And also, the vertex of our ellipse is found here. The one which is the longest side is where we find our vertex, and it is in the form negative a0 and a0. These are points on the ellipse collinear with the center and the foci. So the vertices are collinear with the center and the foci. And also, if we have this one, the vertex is at negative a, 0, and vertex is at a, 0. And also, the line segment v sub 1, v sub 2, from here to here is called the major axis, and its length is always equal to 2a. And it divides the ellipse into two congruent parts. And also, if y equals 0, then x plus a, this one is your x plus a, and x minus a. And each vertex is a units. It is a units away from the center. Let's also have these co-vertices. Co-vertices are your point W sub 2 and W sub 1. And they are represented in coordinates as 0, negative b, and 0, b. It is the segment through the center perpendicular to the major axis and is called the minor axis. It meets the ellipse at its co-vertices. Okay, so it meets the ellipse at the co-vertices. It also divides the ellipse into two congruent parts, from the right part here and the left part. So let's try to name the parts. The points negative 4, 0, and 4, 0. Where can we find this? It is here. Negative 4, 0, and 4, 0. As you can see, it is your F, so it is the focus or foci of our ellipse. Let's continue with number 2. Points 0, 3, 0, negative 3, and 0, 3. As you can see, this is found on the shorter part of your shorter length of the ellipse. So that is your points co-vertices. Let's continue. Line segments whose endpoints are negative 5, 0, this one, and 5, 0. So it's represented by V, and the ellipse passes through it, so we have the vertex or vertices of our ellipse. How about number 4? The line segment. Number 3 is not the vertex, but it's a line segment. So we should call it major axis. And number 4, line segment whose endpoints are negative 3, 0, 0, negative, endpoints are 0, negative 3, and the other endpoint is 0, 3. Sorry for this one. And so, this is what you call the minor axis. And number 5, the points negative 5, 0, this one, and 5, 0. So those are called vertices. Okay, let's continue. Name the part of the ellipse represented by the following points and line segments. Refer to the figure to the right. So those are the points 0, negative 5, and 0, 5. What do you call this one? As you can see, it is a shorter part of our ellipse, not this one. It is perpendicular to our principal axis. So what do you call that? This point and this point that contains our minor axis, it is your co-vertices. Next, the line segment whose endpoints are 0, negative 5, this one, and 0, 5. These are, since it's shorter, we may call it as minor axis. The points negative 12, 0, and 12, 0, as represented by F, you call that as focus, or since it's 2, we call that foci. Points negative 14, 0, and positive 14, 0, we call that as vertices. And also for number 5, line segment whose endpoints are negative 14, 0, and positive 14, 0, we call that as major axis. Okay, so that's all for number 1. I think we should continue with our number 2. What are the coordinates of the following? The center. Okay, so the center is found at the origin, as you can see in the figure on the right. Number 2, where can we find the foci? So the foci is here. X is 0 and y is negative 5. So that's 0, negative 5, and the other one is at 0, positive 5. Number 3, what are the vertices? So vertices are here, and so that is 0, 13, and 0, negative 13. Number 4, the co-vertices. So it's found here. That is 12 since it is on x-axis. So we start with 12, 0, and negative 12, 0. So those are the points that are here in this example. Let's continue. Find the length of the major axis. How can we find the length of the major axis? The one which is longer. So from 0 to 13, that is 13 units. So 2a, that is the measurement of our major axis, and our a is equal to 13. So that is 2 times 13. And so the length of our major axis is 26. Let's continue. Number 6, the minor axis. So the minor axis is from here to here. That's from 0 to 12, and so 2 times b, which represents the length of your minor axis from the origin to the length of half of your minor axis. So that is 2 times 12. And the answer is 24. And lastly, number 7, the distance between the foci. So as you can see, it's from 0 to 5. So that's 2 times c. That's 2 times 5. The answer is equal to 10. That is how we find the length of the line segments that are found in our ellipse. Let's continue. What are the coordinates of the center? Okay, as you can see, the coordinates of the center is at the origin, and so we have it as 0, 0. Number 2, how about the foci? The foci is found here, in here. So that's negative 12, 0, and 12, 0. How about the vertices? The vertex is here, and so we have negative 13, 0, and 13, 0. Number 4, the co-vertices. The co-vertices can be found here. So we have 0, 5, and also 0, negative 5. Next question for number 5, the major axis. Find the length of the major axis. As you can see, from 0, it is 13 units to the left and 13 units to the right. So that's 2a equals 2 times 13 equals 26. Let's continue. Number 6, the length of the minor axis. We know that from the origin, it takes 5 units to your co-vertex. So that is 2b, which is equal to 2 times 5. And that is equal to 10. And lastly, our foci is from 0 to 12. So that is 12 units. 2 times c is equal to 2 times 12. And so the full length of our foci will be, of our line segment containing the foci, is 24. Okay, so that's all for that activity. And also we have here our letter B. I think it would be easier for you to answer now. So for my students in pre-calculus week 3A, you may now take your answer on this one. I don't have to discuss this. Okay, so we are done now with our quarter 1 week 3A, and let's continue with our pre-calculus week 3B. Okay, we are now on standard form of the equation of the ellipse. And the objective is at the end of this discussion, the students will be able to determine the standard form of the equation of the ellipse. And so let us discuss this first. The standard form of the equation of the ellipse is given by this. Let A be greater than C and greater than 0, and B is equal to square root of A squared minus C squared. Then, an equation of the ellipse with the center at the origin. If the center is at the origin and with foci at F C0 and F prime negative C0 and the vertices at A0 and V prime, which is negative A0, that will be x squared over A plus y squared over x squared over A squared plus y squared over B squared equals 1. This will be the standard form of the equation. Take note that at this point, our major axis is found on the x, and the ellipse will be like this one. It's longer, like horizontally. And also, for number 2, if the foci is at 0, C, and the 0, negative C, and the vertices at 0, A, and 0, negative A, then we have this standard form of equation. We have y squared over A squared plus x squared over B squared. Take note that on this point, our principal axis is found at your y. So, it will be a vertical kind of ellipse. It's standing. It's longer vertically. Okay, let's continue. Give the coordinates of the center, foci, vertices, and co-vertices of the ellipse with this equation. Okay, as you can see, we can have our A equals square root of 169. Because this is our A squared, therefore our A is square root of 169, and therefore our A is equal to 13. Let's continue. Let's find our B. This is our B squared. So we have B is equal to square root of 25. And so our B is equal to 5. Now, we are bound to find our letter C. What is C? And this is the distance from the center to the foci. So let's try to check. We have this equation, like B equals square root of A squared minus C squared. And so we can square both sides of the equation. And we have B squared equals A squared minus C squared. And so when we reconstruct this equation, our C will be here in order to find C. So we have positive C squared equals A squared minus B squared. So, therefore, our C is equal to square root of A squared minus B squared. Let's substitute the values. A squared is 169 and B squared is 25. 169 minus 25 is 144. And so, our C is equal to 12. So, we have now the quantities for A, B, and C. We are now able to find the foci, the vertices, and the co-vertices. Let's try. The center is at the origin, so that is at 0, 0. Then, if we are going to find the foci, it means that we have C here, and the principal axis is at x. So, we have the foci negative 12, 0, and 12, 0. Letter C, the vertices. We have 13 units from the center, so that is negative 13, 0, and 13, 0. Letter D, our co-vertices. So our co-vertices will be at our minor axis, and that is 5 units from the center. So that is 0, negative 5, and 0, 5. Those will be the co-vertices of our ellipse. So I think it will be easy for you to solve this one. Let's continue. We have here exercise 1. Okay, so I will not answer our number 1 here. I will leave that for you to answer, but I'll give you the answer on number 2. So let's start. The center is found at 0, 0. That's from the origin. And so let's find first the foci, the vertices and co-vertices. So our A is equal to square root of 169. That our A is 13. Then let's find our B. Our B is equal to square root of 144, and our B is equal to 12. Now, let's find our C. C is equal to square root of 169 minus 144, and that is equal to square root of 25. So our C is equal to 5. So it will be easier for us to find the foci. Okay, the foci is at points 0, sorry, it's not 0, but negative 5. That's our C, which contains the foci. So negative 5, 0, and 5, 0. Next, the vertices. The vertices are from negative 13, 0, and 13, 0. And lastly, the co-vertices, which are 12 here. So we have negative 12. Sorry, it's on y-axis. So we have 0, negative 12, and 0, 12. Those are the parts of our ellipse. So I will leave this answer to you. So it's up to you to get the answer for that. Let's continue with our example 2. Give the coordinates of the center, foci, vertices, and co-vertices of the ellipse with this equation. As you can see, our A now is found here, and our B is found here. So we can interchange that. So our A is equal to square root of 100, and our A is equal to 10. Our B is equal to square root of 36, and that is equal to 6. And so our C is equal to square root of 100 minus 36. And so our C is equal to square root of 64. C is equal to 8. We don't have to take negative values here because there is no such distance as a negative value. So let's continue. The center is at origin, and that is at 0, 0. Let's find the foci. The foci is 8 units from the center, but you can notice that it's here on your y-axis. So that is 0, negative 8, and 0, 8. Next, the vertices. Vertices are also in line with our foci, and our A is 10. So that 0, negative 10, and 0, positive 10. And lastly, our co-vertices, we get B equals 6 from the X. So we have negative 6, 0, and 6, 0. Those are the parts of our ellipse given on example 2. Let's continue with our exercise 2. I think we should answer this number 2, and I will leave this number 1 for you to answer as my students. Okay, so shout out to all the students of Kalinog National Comprehensive High School, especially the grade 11 STEM. So this is your task to answer this one, and I will give you the answer for this one. Okay, so let's find the center first. The center is at origin, so that is at 0, 0. Next, let's find the foci. Okay, so we have here our A. A is equal to square root of 144, and so our A is equal to 12. Our B is equal to square root of 25, and so our B is equal to 5. Now let's find our C. C is equal to square root of 144 minus 25. How much is that? C is equal to 144 minus 25 is 119. So we have square root of 119. Do we have a square root for that? I think there is none. So let's just put it as like this one. And so our foci, since we have at y-axis here, we have a principal axis at y. So we have the foci 0, negative square root of 119, and 0, square root of 119. This is for the foci. And for the vertices, we have 0, negative 12, and 0, 12. And for our co-vertices, we should take our B. We have here 0, negative 5, and 0. It's not 0, negative 5. It's, I really feel sleepy right now. 5, 0, and also negative 5, 0, and also 5, 0. Okay, so these are the answers for our exercise 2. Let's continue for our example 3. This one is a different kind of equation, so let's try to solve this. Give the coordinates of the foci, vertices, and co-vertices of the ellipse with this given equation. So what are we going to do in order to solve this one? Let's erase this first. Okay, so we should divide both sides by 400 so that we can have equal to 1. Okay, so we have 25x squared over 400 plus 16y squared over 400. All we have to do is just cancel these two. So 25 divided 25 is 1, and 400 divided by 25 is 16. So what our answer will be x squared all over 16 plus, then divide also this one with 16, and we have 1, and this will become 25. So y squared all over 25 equals 1. And so if we are going to find our principal axis, it would be here. This is our A, and our B would be here. Okay, so therefore our A is equal to square root of 25, and that is equal to 5. Our B is equal to square root of 16, and that is equal to 4. And so our C is equal to square root of 25 minus 16, and that is square root of 9, which is 3. We have now our 5, 4, and C, which is our A, B, and C. Now, it's easier for us to find the foci, the vertices, and the co-vertices. So, since we have our principal axis at y, our foci will be also at y. That will be 0, -3, and 0, 3. Our vertices will be at A, which is 5, so that's 0, -5, and 0, 5. And lastly, the co-vertices will be found at our X part, so that is 4. We have -4, 0, and 4, 0. Those are the parts of the ellipse that we have to find on our example 3. Let's continue with our exercise 3. I think I should answer this number 2, and again, to my students, I will leave number 1 to you. Okay, so let's have this one. We have to divide both sides by 240 in order to make the right side of our equation equal to 1. So that is 16x squared over 240 plus 15y squared over 240. And so, we have this 16 divided by 240. The answer is 15. So we have x squared over 15 plus y squared. 240 divided 15 is 16 equals 1. And so this will be our basis for A and our basis for our B. Our A is square root of 16. Since we have a square root for that, our answer is 4. And so our B is equal to square root of 15. We don't have square root of that, so our B is equal to square root of 15. And our C is equal to square root of 16 minus square root of 15, which is equal to square root of 1. So our C is equal to 1. We have our A as 4, sorry, and our B as square root of 15. Now, it will be easier for us to find the other parts of our ellipse. So, the center is found at 0, 0. The foci is found at, take note that we have here a y, so we have 0, -1, and 0, +1. The vertices found at 0, -4, and 0, 4. And lastly, the co-vertices found at negative square root of 15, 0, and negative, positive, sorry, that's positive square root of 15, 0. Those will be the co-vertex of our ellipse. So that's it. Let's continue again with our example 4. Find the equation in standard form of the ellipse whose foci is found at 0, -8. Sorry, that's 0, -8. And the other one is 0, +8. I think there is a typographical error with your math packs, so just consider that as 0, +8. So, as you can see, our C is 8 units from the center. So let's have C equals 8. And so the sum of distances from the foci is 20. So it means that our 2A is equal to 20. Divide both sides by 2, and our A is equal to 10. We have our A, our C, and we are now looking for B. Our B is equal to square root of A squared. So that's 10 times 10, we have 100, minus C squared, which is 8 times 8, which is 64. So that is equal to square root of 36, and so RB is equal to 6. We now have our A, B, and C, so it will be easier for us to find the equation in standard form. So we have x squared. Take note that the focus is at y. So let's start with y squared first so that we will not find it hard. So y squared over our a squared, which is 100, plus x squared over our b, which is 36, equals 1. This will be the standard form of that equation of the given in example 4. Let's continue. Okay, so for exercise 4, let's have this number 1, and you will be the one to solve for number 2. Okay, so the focus is given at 0, -3, and 0, +3. Take note that it's also on your y-axis. And so, our equation must be y squared all over blank plus x squared all over blank equals 1. The distances from the foci is given as 10. So 2a equals 10, and so our a is equal to 5. So if we have 5 here and our a squared must be here, so we have y over 25. Let's find our b. Given that our c is 3 units from the center, so we have b equals 3. And so to find c, sorry, it's not b but c. Our focus is represented by c, so that's c. And we are going to find our letter b. So that is square root of 25 minus 9. 25 minus 9 is equal to square root of 16, and b is equal to 4. Okay, so therefore our b squared is 16. This will be the equation for this number 1. And I hope that you can easily answer the question on number 2. But take note that on this case, our principal axis is found at x. Okay, so that's at x, and our 2a is equal to 26. I hope that you can apply all the things that we have discussed to answer this number 2. We are done with our quarter 1 week 3B. Congratulations, and I hope that you are happy that we are now on our week 3C. This is the last part of our topic for this week. We are now on standard form of equation of an ellipse, and our objective is at the end of this discussion, the students will be able to determine the standard form of the equation of the ellipse. Okay, so let's have this again. If the ellipse is not at the origin but has the center at HK, given the same situation, we have this standard form. Okay, this one and also this one. So, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. And the other one, if your principal axis is at y, then we have y minus k quantity squared over a squared plus x minus h quantity squared over b squared equals 1. Let's have this example. Give the coordinates of the center, foci, vertices, and co-vertices of the ellipse with this given equation. So, let's find the center first. Since we have x minus h, so our center will be -3, and our y is minus k, so we have -3, 5. Now, let's find our a, b, and c. Notice that the principal axis is at y. So this is your a squared. A squared equals 49. And so the square root of 49 is equal to 7. That will be our A. And let's find our B. Our B is square root of 24. B equals square root of, the factors of 24 are 4 times 6. And that is 4. B is equal to 2. So that's square root of your 4. Square root of 6. That will be your B. And let's find our C. C is equal to square root of 49 minus 24. 49 minus 24 is equal to 25. So we get C equals square root of 25. And so our C is equal to 5. Okay, so we have now our A, B, and C. It's easier for us to find the foci, the vertices, and the co-vertices. So let's find first the points of our foci. So we have to refer at C, and we have to move at Y. So we will remain negative 3 here, but we have 5 plus 5, which is 10. And also, we have negative 3, and 5 minus 5, which is 0. So this will be the foci of our ellipse. Let's have the vertices. Okay, we have 7 units from the center. So that is negative 3. 5 plus 7 is 12. And negative 3. 5 minus 7 is negative 2. Those are the vertices of our ellipse. And lastly, let's find the co-vertices. The co-vertices is found at, take note that your x will move here. So we have negative 3 minus square root of 2, minus 2 square root of 6 rather, minus 2 square root of 6, and the coordinate is 5. And for the other one, we have negative 3 plus 2 square root of 6, positive 5. That will be for our example 1. Let's continue with our exercise 1. So, we have this one. I think I should answer this, number 2. Okay, so the center is at x minus h and y minus k. So our h is 5. Let's find out. The center is at 5, 3. Now, this is our a squared. This is our b squared. So we have a is equal to square root of 100, which is equal to 10. Or b is equal to square root of 64, which is equal to 8. And so our c is equal to square root of 100 minus 64. And that is square root of 36. C is equal to 6. It will be easier for us now to find for the other parts of our parabola. The foci will be found at, since the principal axis is at y, we have to add on y. So we have 5, 3, we have 3 plus 6, 3 plus 6, we have 9, and 3 minus 6, we get 5, negative 3. Okay, and so the vertices are found at, that's for A, we have 5, 3 plus 10 is 13, and 5, 3 minus 10 is negative 7. And lastly, the co-vertices are, let's move on x. We have 5 and 8 here. 5 minus 8 is 13. 5 minus 8, 5 plus 8 is 13. 3. And 5 minus 8 is negative 3. 3. Okay, these are the coordinates of our co-vertices. Let's have our example 2. Okay, at this time, our principal axis is found at x. So we have HK, our center, at negative 1, which is the partner of your x, and your y is negative 1. Your h is negative 1 and your k is negative 1. Our a squared is equal to 100, and so our a is equal to 10. Our b squared is equal to 36. This one is our b squared. This one is our a squared. So b is equal to 6. Let's now find our c. That's equal to square root of 100 minus 36, which is equal to square root of 64. And so our c is equal to 8. Okay, so since we already have our a, b, and c, it's easier for now to find the foci, vertices, and co-vertices. Let's find the foci first. It's on, since we have here the principal axis at x, we have to move at x. So we have negative 1 plus 8, we have 7. 7, negative 1, and negative 1 minus 8 is negative 9, negative 1. So the vertices are, we have 10 units from the x, from negative 1. So negative 1 minus 10 is negative 11, negative 1, and negative 1 plus 10 is positive 9, negative 1. And for our co-vertices, we have to move at y. So we have negative 1, but we have to add 6 on here. Negative 1 plus 6 is 5. And also, negative 1 minus 6 is negative 7. So these are the parts of our ellipse. Let's have this exercise. So I think I have to solve for this one. Number 2 again. Okay, so the center is at negative 4, positive 2. And our a squared is equal to 25. So our a is equal to 5. Our b squared is equal to 9, and so our b is equal to 3. Let's solve for the other one. C is equal to 25, square root of 25 minus 9. And C is equal to square root of 16. So C is equal to 14. Sorry, it's not 14, but 4. I really feel so sleepy. Sorry for that. Okay, so C is equal to 4. And so it will be easy for us to find the other parts of our ellipse. So the vertices, the foci will be at, since it's at x-axis, so we have to move at x. Negative 4 plus 4 is 0, 2, and negative 4 minus 4 is negative 8, 2. The vertices will be at a is 5, so we have negative 4 minus 5, that is negative 9. So negative 9, 2, and negative 4 plus 5 is 1, 2. And the co-vertices, we have here are 3. So that is negative 4, 2 plus 3 is 5. And negative 4, 2 minus 3 is negative 1. So those are the coordinates of our co-vertices. And so, let's have our example 3. Okay, so we have here our example 3. all we have to do is complete the squares for this. So we have 9x squared plus 16. Sorry. 9x squared minus 126x blank plus 16y squared plus 64y blank equals 71. Okay, so we have to look for a number that we can add here. But first, it will be easier for us to do that when we divide this by 9. So we will deal with smaller numbers. So we have 9 times x squared minus, what number will you multiply to 9 that will get 126? Or that's simply 126 divided by 9. So we have 14. 14x. And so we have a blank here. Plus, let's divide this with 16. So we have 16 times y squared plus 4y plus blank equals 71. What we are doing now is completing the squares. So how are we going to find the third element here? From our last lesson, we have divided by our b here with 2 and squared. So we have negative 14 divided by 2. The answer is negative 7. And so to square that, we get 49. So we have to add 49 here. But take note that we still have a multiplier of 9 here on the left. So if we add 49 here, we have to multiply it first by 9 and add also the quantity here, so that this equation will still be equal. So what will we add? That is 49 times 9, that is 441. Okay, and for here, we have 4 over 2, that is 2. 2 squared is 4, so we have add 4 here. 4 times 16, that is 64. So we have to add 64. 441 from your x here, 49 times 9, and 64 from your 4 times 16. So we now have 9 times, express this as a square of a binomial. So we have x minus 7, quantity squared, plus 16. Then we have y plus 2, quantity squared, equals 71 plus 441 plus 64. We get 576. Now, in order to have 1 here on the right side of your equation, you should divide both sides with 576. And just like what we did last time, in our previous lesson, all we have to do is cancel. So 576 divided by 9, the answer is 64. We get x minus 7, quantity squared. We have 64 plus y plus 2, quantity squared. We get 36. Okay, so 16. Cancel that, we get 36. If we cancel this one, we get 64. And so that's equal to 1. So this is our a squared, this is our b squared, and so let's find our c squared later on. Okay, so the center of our ellipse will be at 7, negative 2. The foci will be at, take note that your a is 64, a squared is 64, and so our a is equal to 8. Our b is 36. B squared is 36, and so our b is equal to 6. And let's find c. Our c is equal to square root of 64 minus 36. How much is that? 64 minus 36 is 28. So c is equal to square root of 28. But since 28 is equal to 7 times 4 and 4 has a square root, so our C is equal to 2 square root of 7. This will be the quantity of our C. Our A is this one and our B is 6 units from the vertex. So our foci will be, take note that a principal axis is at X. So we have the change in X. So we have 7. 7 plus 2 square root of 7. And the other one is negative 2. And 7 minus 2 square root of 7. Then the y coordinate is 2. And let's find the vertex. Vertices, rather. The vertices will be found at 7 plus 8, we get 15, negative 2, and 7 minus 8, we get negative 1, negative 2. Our co-vertices will be at 6, so we get 7. Negative 2 minus 6 is negative 8, and 7. Negative 2 plus 6 is positive 4. So these are the co-vertices of the given equation in example 3. Let's continue with our exercise 3. I think I should answer number 1 only so that we could save time with our discussion. Okay? Exercise 3. Oh, where did I get my exercise 3? Okay, so we have 9x squared plus 72x blank plus 16y squared minus 96y equals negative 144. Okay, so let's have this. 9 times x squared plus 72 divided by 9 is 8x. So, what we have to add here is 8 divided by 2, we get 4, and 4 times 4 is 16. Okay, that's it. Plus 16 times y squared minus 96 divided by 16 is 6, so we have minus 6y. Plus 6 divided by 2 is 3 times 3, we got 9, equals negative 144. So, 16 times 9 is 144, and also 16 times 9 is still 144. Take note, this will become 0. And so we have 9 times x plus 4, quantity squared, plus 16 times y minus 3, quantity squared, equals 144. And so we have to divide 144 on both sides of the equation in order to get the standard form. So 9 divided by 144 is 16. So I think it's x plus 4, quantity squared all over 16, plus 144 divided by 16 is 9. So we get y minus 3, quantity squared all over 9 equals 1. This will be the standard form of our equation. Let me erase this one so that it will be easier for us to solve for A, B, and C. Okay, just bear with me while I'm erasing this one. So I hope that my students will still find it easy to answer this. Okay, so our A squared is equal to 16, and so our A is equal to 4. Our B squared is equal to 9, and therefore our B is equal to 3. And so let's find our C. Okay, So our C is equal to square root of 16 minus 9, and that is equal to square root of 7. Okay, our C will be equal, that's 16 minus 9 is equal to 7. So our C is equal to square root of 7. B is equal to 3. Okay, so our foci will be at, we have change in x, so we have, let's find the center first. The center is at negative 4, 3. So our foci will be at negative 4 plus square root of 7, 3, and negative 4 minus square root of 7, 3. Our vertices will be found at negative 4 plus 4, we have 0, 3, and negative 4 minus 4 is negative 8, 3. And our co-vertices will be found at negative 4, 3 plus 3 is 6, and negative 4, 3 minus 3 is 0. That will be for our answer on number 1, exercise 3. And we are done now with our quarter 1, week 3C, and I hope that you have learned a lot from me. Thank you for watching this video, and I hope that you will still watch my future videos when I feature our pre-calculus week 4 and so on. God bless everyone! For those who are new to my channel, just subscribe to my channel, click subscribe, and hit the notification bell to be updated of my latest videos. Thank you for watching, and I hope you learned a lot from me.